Welcome to H2Ology. I'm Dr. Chris Anastasiou, Chief Water Quality Scientist.
And I'm Dr. Mark Fulkerson, a Chief Professional Engineer. This is part one of our four-part series on watershed management.
In this segment, we are exploring the natural story of flooding. We're going to talk about watersheds today and watershed management. So a lot of people probably have no idea what those words mean together. But watersheds are important because everyone lives in one. So it's pretty relevant.
Right. And in basic terms, Chris, a watershed is an area of land that when water hits it, it could potentially flow down to a common area. And so when we think about watersheds, the boundaries of a watershed are usually high ground, kind of like a ridge. In the sense of hydrology, when rainfall hits the edge of a watershed, it's either going to flow one way or it might flow the other way down the hill towards a different river or lake system.
So Mark, tell us a little bit about the Watershed Management Program here at the district.
Basically, we recognize that there are a lot of flood-prone areas in our region, and people are impacted by flooding. So what we try to do with this program is we're going to partner with local governments to develop projects to say, okay, let's develop a model. Let's put together a model that simulates the landscape in a certain watershed, so we can simulate rainfall on it and map out where those high-risk flood areas are.
Shall we introduce our special guest today?
Absolutely.
All right. So why don't you do the honors, since you probably work with Scott a lot more than I do.
I do, Chris. Yes, I am in the Engineering and Watershed Management Bureau, and Scott Letasi is our Bureau Chief of Engineering and Watershed Management, and he'll be here today. And Scott's got a lot of history and a lot of background, don't you, Scott? Because you're not only the Bureau Chief today, but you really worked in the cutting edge of this program early on, and did a lot of the things to kind of get it set up for us.
Yes, absolutely. So thanks for having me. I started my career here at the district in the Watershed Management Program. So I've been here almost 20 years, and the Watershed Management Program really is quite exciting in terms of the technology that we use and the cutting edge science and engineering that we have here at the district to understand flood protection.
Very cool. I'm looking forward to hearing all about that. So I have to tell you, admittedly, I am not, I am familiar with the Watershed Management Program, but I'm very excited to learn, really to take a deep dive into what the Watershed Management Program does, what watershed management plans are, and we're going to talk a lot about kind of the science behind flood risk.
Flooding is something that you're going to deal with no matter where you are in the world in certain areas. It's a natural phenomenon. It's something that impacts people in a negative way, but we're going to definitely dive into the nuances of flooding and to talk about the science behind it.
And just to remind our listeners and our viewers that the Water Management District has really four basic areas of responsibility or core mission areas, and that's water quality, natural systems or habitat, water supply, and then flood protection. And we know based on recent times that flood protection has been on the forefront of a lot of people's minds. So it's a very important mission set that we have here at the district.
Absolutely, Chris. We've gone through in our region some pretty extensive flooding this past year, but also in our state, elementary school students, second grade, they're learning about the water cycle, and such a simple concept that the kids can learn, but it really is the big driver to all of our water resources, our rivers, our aquifers, our lakes, our wetlands. They're all dependent upon rainfall. Mm-hmm. And so, without rainfall, we're not going to have that source of water to our water resources. And a large portion of the rainfall evaporates back up to the atmosphere. Smaller percentage of it soaks down into the soils and refills our aquifers. Yep. And then the last component is what doesn't evaporate, what doesn't soak into the ground is going to run off the surface, and it's going to collect in a lower lying area. And that's why sometimes when we see periods of heavy rainfall and maybe where it just keeps raining and raining, that water keeps collecting, it's going to start stacking up on the surface. And that's where we see flooding on the landscape.
And given that Florida, we have a relatively flat landscape, the water doesn't move that fast in terms of it, flowing down through the watershed, and a lot of times it'll pool, like you're saying.
Right. Our river systems, they're not like mountainous river systems.
Yeah.
They may drop a foot in elevation over a mile or more than a mile, and so you look at a river and it just looks like it's flat. It is sloping down, but it's a very gradual thing that's going on.
Not a good place for whitewater rapid if you're into whitewater.
Not here in Florida.
Not in Florida. Although I will say, just as an aside, there is that one little section of the Hillsborough River where it can get up to, like, I believe, Class 1 rapids at certain times of the year. So
yeah, because of that lime rock that just pushes up through the channel bottom and creates some
Hey,
flow.
we'll take what we can get around here. When people think about flooding, they typically think of it in kind of the sense of it being a natural disaster. That's usually when people pay attention, is when things are, really getting bad. But it's also, like, and you alluded to this, it's an essential part of the natural cyclical pattern of the environments that we have. I mean, we've got a lot of wetlands in Florida, and this district especially, we have a lot of wetlands. So can you guys talk a little bit about, like, putting flooding into more of a natural context?
Right, absolutely. So our district land area is about 10,000 square miles, Chris, and nearly 25% of that 10,000 square miles is wetlands. And these wetlands are an important part of the land because they are lower lying areas. They're where that rainfall collects and where floodwaters are gonna be stored. And they're also an area that acts as a natural filter to kind of clean out any contaminants that might be in that water before it's making its way into the ground or into a river system or something like that. So wetlands are definitely a very, very important thing. But when we talk about flooding, it is certainly a very, very difficult thing for folks to deal with. If a storm blows through and knocks a tree down in my yard, okay, I can chop that tree up and go on. But if I've got water covering my property or seeping into my home, and there's nothing I can do to stop that from happening, that is a very dire situation to be in.
Yeah, it's unfortunate. It does happen, and part of it too is that there are Florida's seen a big growth, continues to see a big growth in population, and so one could argue that many of these areas that used to flood, maybe flooded out a few cows, but now you've got these developments. It's just the same. It's the same story along the coast where storm surge becomes an issue. Storm surges have been around forever. Flooding has been around forever. What has changed is that now we have people living in those places, and so it becomes a real challenge for us because we're trying to manage all of that.
Absolutely. Our development is encroaching into lower lying areas, and of course the development has regulations put in place to be able to store that excess storm water and release it at the rate that it would have come off the land naturally.
Right.
But it's still the same amount of rain coming down, and that rain, when we get excess rainfall or when we get a hurricane or something like that, it is a lot of water hitting the surface of the earth that's got to go somewhere. And we can't just shunt it off to the side or divert it over here. It's going to go where it's going to go, and it's going to fill up those low-lying areas, whether it is a natural field or wetland or it is the lowest part of the neighborhood that you live in.
Yeah. And it seems like in recent years we've had these 100, 500, even 1,000-year events that are not things that you typically see, but an event where you're dropping 20 inches of rain in a 24-hour period. You can protect an area just so much, but that's a lot of rain that falls in a very short period of time, and it's got nowhere to go.
Absolutely. And we always kind of say, flooding has happened before. Flooding will happen again. When we go through a flooding event, it's nothing new. So at some point in history, that area has experienced that kind of water, but maybe the landscape has changed and there's more people in that area. But Scott, maybe you could kind of explain what Chris just talked about, a 100-year storm or a 500-year storm, what that design storm means, because those are the storms that we use when we run our watershed models.
Yeah, absolutely. So for our watershed management plans, we're using these theoretical rainfall events. And so they are actually matching what we use in our regulatory process as well to issue permits, these environmental resource permits. And so when we build these watershed models, we're making sure we understand what the landscape is, and then we're going to apply these rainfall events, these theoretical rainfall events. And so the one that we typically use the most at the district here to understand where it's going to flood is this 100-year storm event. And so essentially that is saying that rainfall event has a 1% chance in every year to occur. And so what we do as part of our watershed modeling is use that rainfall to understand where is it going to flood, because that's been the most essential question that we're trying to answer as part of the Watershed Management Program. That is really the problem that has occurred and came to existence. Our Watershed Management Program is, where is it going to flood? And so we've been trying to answer, that question over the last few decades. Now the questions have been changing, and we're answering questions in a different, that are coming from all different types of stakeholders. So it's difficult enough, our watersheds are complex enough to just understand where it's going to flood, but everyone is trying to ask questions in terms of, well, how deep is it going to flood? How long is it going to be there?
Yeah.
And so we're able to answer those questions, and really with the advancements in technology, we're going to be able to answer these questions a lot quicker.
That's
so
awesome.
hopefully we'll talk a little bit more about, the advancements in technology and how we're able to utilize it in our watershed management program.
Yeah, we're going to talk a little bit about, we're going to actually talk a lot more about mapping and the actual process by which we do these flood risk mapping as part of the watershed management plan. I wanted to ask this question, and I hope I asked this correctly, but so you talked about 100-year, we talked about 500-year flood events and what that means from a probabilistic standpoint. But when you look at the climate record, and in some cases, sometimes it can go back as far as like the late 1800s. So we have a lot of rainfall data that goes back many years. But it seems like the last 30, 40 years, what would qualify as a 100-year event may be different from what it would look like if you take the full period of record. In other words, if we're getting more frequent, more intense rain events, and this is maybe over the last 30 years, as part of this process, do you look at more recent data and maybe compare what a 100-year flood event might look like based on the last 30 years relative to the last 130 years?
Yeah, that is definitely a challenge, is that, these theoretical storms are based on historical data, statistical analysis performed to be able to understand, what that what that rainfall depth is, and the distribution of that rainfall. As you gain through the years more and more data, that analysis may result in different types of amounts. Moving forward and looking at these challenges, if rainfall is changing, or if we want to know what is even possible, because there may be some storm events we haven't seen yet. We want to look at what is the probable maximum precipitation. That's an event that we can look at to see, well, what is the worst case scenario? And those are type of things that we're looking in the future as opportunities to let people know what is possible. And so that's the biggest thing as part of our watershed management program, is to provide, information, education, and just let people be aware of, what is possible so they can make their own decisions about the impacts they have from flooding.
Chris, you talked about our rainfall record, and that's how we define those design storms that Scott was talking about. So when we come up with maybe 10 inches of rain in a 24-hour period, or 12 inches of rain in a 24-hour period, that we're saying that is the 100-year storm. Well, it's based on the fact that it doesn't rain 10 inches or 12 inches very often in a day. Right. It's got a very small probability of that occurring. And Scott, mentioned, hey, that's the 1% chance storm.
This wraps up part 1. Stick around for part 2, where we'll go behind the scenes of flood risk mapping.